Differential calculus describing the accurate fashion the way such that related to the quantity of change and its rate of change were called velocity. We know that Sharaf ad-Din Al-Tusi followed the teaching from Omar Khayyam, but apparently Khayyam failed to find the solution of algebraic for the equation of quadratic and cubic. It is due to they considered and recognized the positive coefficient and roots only. So, Al-Tusi has come out the idea of treatise concerning cubic equation in 12th century. This treatise had developed concepts related to differential calculus, for instance, to find minima and maxima of the curve and the derivative function. So, according to Al-Tusi, in order to determine the solution for the equation, the function on the left-sided must reach the value of t. If this condition fails to fulfill, it will lead no solution for that equation. Tusi proved the maximum value from the equation is x equal to 2b over 3 and d equal to 4b cubed over 27. Next, we're moving on to the contribution that has been made by Isaac Newton in the last third of the 17th century. He used the methods of infinitesimal, or the equation with the infinite number of roots. For example, there is a curve with the area z in which the infinitesimal increase in x is denoted by O. Hence, the area bounded by the curve would be this equation. Then Newton used binomial theorem to solve and obtain y equal to max power m minus 1. This y value of the curve is actually the rate of change in x, and according to Klein, we call as the fundamental theorem of the calculus, in which the area of the curve can be attained by reversing differentiation. Next, there have two significant variables that been used by Newton in his explanation, known as fluence and fluxion. Fluence refers to the variable quantity with the notation of x and y, while fluxion means variable rates of change. In modern notation, we use dy over dt. Hence, in our modern notation, we will write as dy over dt. It is due to dy over dx is equal to dy over dt divided by dx over dt. For the conclusion, total cost is an antiderivative of the marginal cost, while distance is an antiderivative of the velocity. And as the economist, we will apply this thing in order to know how the changes in the price will affect the demand for the product.